Let's review graphing, in particular both parent functions as well as the transformed functions. So the very first thing we're going to do is take a look at our equation and talk about what is the parent function, and I kind of give it to you over here, and then as well talk about the transformations being done. So because this is a parent function of x squared, then we know that it's going to look like a U shape. And then we start looking at all the transformations. If we take a look at inside the parentheses, we're going to see that inside the parentheses we have x minus 3. We're going to set that equal to 0, and I'm going to solve for x and find that x is equal to a positive 3. This means that we have a horizontal shift 3 units to the right, to the positive side. When we take a look at the outside, we're going to see that we have a plus 4. So we actually, that plus 4 that's on the outside is going to be a vertical shift upward. Now that's left is the multiplier that we have out here on the outside. And what it's doing, this value here, this 2, is actually going to be I'm going to write that down, that it is a multiplier of 2, and it's multiplying the y values. Why the y values? Because it's on the outside of our function. If it was on the inside of our function, it would be inside, right next to the x, inside the parentheses. So with all these different things, we're still going to have a U-shaped graph, and we're going to see that it's going to be shifted, and we're going to have a multiplier of 2. So let's take a look at the parent function p of x, where p of x is equal to x squared. From our list of parent functions, we know that we should have points of 0, 0, 1, 1, 2, 4, because 2 squared is 4, and we can also probably squeeze in 3, 9. Also notice that we can pick in negative values. Negative 1 squared is going to be a positive 1, and negative 2 squared is going to be a positive 4. So we can see our parent function right here. I graphed 0, 0, 1, 1, 2, 4, 3, 9, and by axis of symmetry I can do the same thing on the left side. Over 1, up 1, over 2, up 4, over 3, up 9. And this is our parent function. So we're going to compare our parent function to that of our transformed function. So the first thing I'm going to do is I'm going to get my shifts and create what I call a new axis. So I'm going to go 3 units to the right. That's right here at x is equal to 3. And x is equal to 3 is a vertical line. So I'm going to go on ahead and draw this vertical line. And then we're going to go up 4, and that's going to be right here, and that's going to be a horizontal line, which we'll call y is equal to 4. This is what we call our new origin, our new axes. So now we're going to use the same points that we have for our parent function, except we got to make sure we remember that multiplier. So we're going to have to multiply my y values times 2 and get 8, 2, 0, 2, 8, and 18. So what I did is I multiplied 4 times 2, and that's how I got 8. 1 times 2, that's how I got 2. 0 times 2, I still get 0, and you can see that going forward. So what does that mean to us? That we're going to graph these x values along with these y values, starting at my new origin. So notice we have the point 0, 0 right here. So I'm going to graph that point. Notice on my new axes, or my new origin, is going to be right here. That's where 0, 0 is. Then I'm going to go the 1 to the right and up 2. So from here I'm going to go over 1. Normally we go over 1, up 1, but because we have a multiplier of 2, I got to get that y value and multiply it times 2. And that's why you see it at over 1, up 2. The next point I'm going to see is going to be go over 2 and up 8 from your new origin. So from my new origin, I go over 2 and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's where my point is going to be. Think about it like this. I went over 2, and normally we go up 4. 1, 2, 3, 4, but then I have to go double that because there's a 2 in the front. That's why I had to go the extra 4 up. And I can do the same thing using symmetry, going over to the left 1. Normally we go up 1. The multiplier says go up 2. Go over 2, normally go up 4, 1, 2, 3, 4, but the multiplier says times 2, so 1, 2, 3, 4 again, and we'll see that this is what my transformed parabola looks like. We can see that we had a vertical stretch, so it stretched it up a little skinnier, and we can see that it had a horizontal shift as well as a vertical shift. Let's go to the square root function, and let's say we have our parent function of square root, and we're also going to graph this transformed one. So let's first talk about our parent function. We know that our parent function is the square root, so it's going to look like this, like an arm. Let's take a look at what our transformations are. We can see that inside we have a horizontal shift, so I'm going to do x plus 3 is equal to 0. Solving for x, it says subtract 3 to both sides. I get minus 3. So I'm going to go 3 units to the left. We can actually start graphing that. X is equal to a negative 3 is right here, a vertical line. Let's take a look at our horizontal shift. A vertical shift, because we just did the horizontal shift. Vertical shift says up 2, so up 2, that's going to be our y movement. So we're going to go up 2 units. So I'm going to go up 2 units. I'm going to still put it in my yellow guy. So here's y is equal to 2. And then that's our new origin. Let's take a look at any multipliers we might have, and we can see we have a vertical compression, so we do have a multiplier of 1/2. So we got to keep that in mind. So I'm going to write that down. We have a multiplier by 1/2. So what does that mean to us? That if we get our parent function, remember we're plugging in x into the square root of x. We know we don't have any negative values because the square root of a negative number is going to be not real. So we're going to start off with 0. The square root of 0 is 0. 1, the square root of 1 is 1. The next one I'm going to pick is 4 because the square root of 4 is 2. The next one is 9, and the square root of 9 is 3. So our parent function was right here at the real origin, and it went up over 1, up 1, over 4, up 2, and over 9, and up 3. So this is what it looks like in terms of our parent function. In terms of our transformed function, we're going to actually start here at my new origin. Don't forget that multiplier. And we're multiplying the y values. So I'm going to multiply my y values times 1/2. That's why we're getting the 1/2 square root of whatever. So when I multiply 0 times 1/2, I get 0. 1 times 1/2 is 1/2. 2 times 1/2 is 1. 3 times 1/2 is 3.5. 3/2, sorry, 3/2. So we're ready to graph. I'm going to graph the points 0, 0, which I did. That's this blue dot. Then I'm going to graph 1, 1/2. Normally we would go over 1, up 1, but because our multiplier is 1/2, we only get to go up 1/2. Then I'm going to graph the point 4, 1. Normally we go from our origin, we go 1, 2, 3, 4, and up 2, but because of my multiplier of 1/2, I only go half of 2, which is 1. And then I'm going to graph the point 9, 3/2. That's just the same thing as 1.5. So I'm going to go over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then up 1.5. Normally we would go up 3, but half of 3. So I only went halfway up. And this is what our graph looks like. It still has the same basic shape of our parent function, except we can see how it has been compressed downward towards my y is equal to 2 axes.